Now go for the 12th question. What will be the magnitude and nature of the force in member AB of a truss with the loading and support system as shown in figure? First tell me whether it is a statically determinate truss or not. How to know whether it is a statically determinate truss or not? How many members are there? 1, 2, 3, 4. 4 members. How many joints are there? 1, 2, 3, 4. So J equal to 4. So what will happen? M2J minus array. M2J minus 3. M is how much? 4. 2J. 2 4s are 8. 8 minus 3 is 5. So 4 is not equal to 5. This is M is less than 2J minus 3. So is it a statically determinate truss or not? If M is less than 2J minus 3, it's not a structure at all. It's a some mechanism. It is not a structure. It can move. It can move. Am I true or not? Where is the mistake we have done? See, even though he didn't give, there is a member. So we have not taken this into consideration. I told in the starting, he has given a 2-member truss, but it is having 3 members. The wall, whatever is supporting it. If it has given a member, you take that. Otherwise, still the wall is a member. So how many are there in total? 1, 2, 3, 4, 5. So M is not 4, M is 5. If this is 5, then this is equal. So M equal to 2J minus 3. Hence it is a statically determinate truss. Very good. As it is a statically determinate truss, no need to check every time, sir. He will definitely give a statically determinate truss. There is no doubt in that point. But eventually I kept it so that you will not forget that there is a member, because while you are cutting, if you are cutting like this, then not only these two, there is a third force also. You have to remember this. Not only these two, there is a third force. You have to remember this. Are you okay? Now shall we start? Now please. How many are there? 1, 2, 3, 4 joints are there now. Okay. Now what is he asking? Find the load in the member. AB, right? Find the load in the member AB. This is the member AB. Now tell me how to solve this. Now I have the possibility to updo even with method of joints, because I have 4 now. Previously there are only 3. If I go with method of I have the possibility to do with method of sections. Why? Because previously I have only 3. When there are only 3, if I cut 2 are coming on one side and 1 is there on the other side, so it's not going to be a body. Hence I am not able to go with method of sections. Now I have 2 and 2, so I can go with even method of sections here. Now tell me which one is preferable, method of joints or method of sections? How to go here? Now see, I want to find the what's that load in the member AB. Now tell me what to do. Listen. If I go for B, how many are there? 1, 2, 3, 4. But with method of joints, at max I can solve only 2. If I go at A, 1, 2, 3, 4, 2 support reactions are there, and I have to find the support reactions. First I need to find support reactions. After getting these 2 support reactions, then how many are there? Only 2 are there. I can solve. One way is find the support reactions, then go with method of joints at A. But here I don't want to do 2 steps. Is there any way I can get with 1 step? That is with method of sections. Listen. How to cut it so that I can just solve with 1 step and get the answer. Please, all of you see here. What are the rules to do the sectioning? Sectioner cut the truss into 2 parts such that my member of interest AB will also have to be sectioned. Should be sectioned. Sectioner cut the truss into 2 parts such that my member of interest, here was the member of interest, AB need to be sectioned. First thing. Second, what is the second point? Take care that none of the joint is isolated. Next, third one. Not more than 3 unknowns are created. Not more than 3, because it's a CGFS, it will form a CGFS. 3 unknowns are created. So these are the 3 conditions. I am adding 4th one. Now I am adding 4th one. If there is a possibility, it's not a condition. If there is a, first 3 are compulsory. What's that? My member need to be sectioned, none of the joint is isolated, not more than 3 unknowns are created. The fourth one, if possible, try to keep both the supports on the same side. If possible, try to keep both the supports on the same side. Now tell me, what is the possibility to cut this? See, if there are 4, only possibilities to cut are like this and like this. But if I cut like this, I mean vertically, this member will not be sectioned. So the only possibility I have to section is, the only possibility for me to section is this, that's it. Now, listen. First condition, section or cut the just such a way that my member of interest is sectioned. Yes, it is sectioned. Next, take care that none of the joint is isolated. On this side there are 2, on this side there are 2. I have taken that care. Next, not more than 3 unknowns are created. Now it's cutting at AB, BC, and then CD. How many? 3. Only 3 unknowns are created. The third condition is also satisfied. Not more than 3 unknowns are created. I told if there is a possibility, it's not a condition. Yes, I got the chance that I kept both on the same side. Why I am imposing this third one? Why I am imposing this third one is, listen. If suppose one support is on one side and one support is on another side, I have to find support reactions. If I keep both of them on the same side, now I draw the free body diagram of the other side so that no need for me to find the support reactions. I will draw the free body diagram of the other side so that no need of finding the support reactions. Are you getting me? But in all the problems, that possibility will not be there. If that possibility comes, try to keep it on the same side. Okay. Generally in GATE, as you have less time, majorly 75 to 85% of the problems you will give such a way that both the supports can be kept on the same side, so that no need of finding the support reactions. Directly you can draw the free body diagram of BD. Okay. So first step is find the method of, same as method of joints, that is find the support reactions, but don't do that. That is a conventional method. Here what I do, I will first cut and check whether it is required or not. Here it's not required, so I'm not finding the support reactions. Now what to do, as both the support reactions are on this side, draw the free body diagram of the other side. What is the other side? BD. Draw the free body diagram of the other side, that is what? BD. Please, all of you, listen. Don't be in a hurry. Free the body from everything and draw the sketch. Free the body from everything and draw the sketch. BD, right? Free the body from everything and draw the sketch. Done. This is my B. This end is B. This end is my D. This end is my D. Okay. Next. Actions. What are the actions? At B, I have a 600 kilonewton load vertically down, and at D, I have a 800 kilonewton load making an angle of 60 degrees with the horizontal. Now, please, all of you see here. At B, I have a how much? 600 kilonewton load. 600 kilonewton load, right? So 600 kilonewton load vertically down and 800 kilonewton load in this fashion at an angle of 60 degrees. Okay. This is 600 kilonewton. This is 800 kilonewton. And it is at an angle of 60 degrees with the horizontal. It's at an angle of 60 degrees. Free the body from everything and draw the sketch. Done. Actions done. Next, what to do? Reactions. What are the reactions? Tell me. See, it's cutting the members AB, BC, CD, right? So as it is cutting the member AB, I'll get one support reaction there, right? Now, please, all of you see here. Sorry. This is vertical, so vertically I'm taking this is vertical, so I'm taking vertically. Okay. Yes. Next. This is 3, 4. I'll say let us say this angle is theta. Just I'm taking this angle. You can take even what the vertical, okay? With the horizontal, I'm taking an angle theta, right? Now there's one more force like this. FBC, right? Next, it's cutting the third member. It is also vertical, so I have here this one. Okay. Now this is FAB. Sir, how is that? How is the force? I told already. Along the member towards the joint. If it comes positive, my assumption is correct and it is under compression. If it comes negative, it is in tension and it is in the opposite direction. Okay, now this angle is theta, FBC, FCD, right? This is making an angle theta with the horizontal, FBC, and this is FCD. This is FCD. Now, so before going to the problem, first resolve it. See, first resolve this 800 kilonewtons. This will become how much? 800 adjacent side. So cos 60. This will become 800 sin 60. Now, next one is what? FBC. Resolve this. Any other color? I'm not having some good colors here. Tomorrow I have to sit and add them. FBC. So this is FBC cos theta. Here I will have, see, it is like this towards FBC cos theta, adjacent side. This is FBC sin theta. I don't think this is much visible. I won't close it. Next, anything else? So done. Now, what is my target? He asked her to find the force in a member AB. Now tell me how to get it. See, FAB, that is in which direction? Y direction. In Y direction, what are the forces I have? FBC sin theta, FCD. So along with AB, I have two more unknowns. So what else I can go? One more option is go with the moments. How to go with the moments? If I sit here, FAB will be eliminated in the equation. So where I have to sit? Go and sit here. If I sit here, CD will be eliminated. Even this BC will be eliminated because it is passing through this. But still in Y direction there is a BC. This will come. So how to get this BC? I have to find BC at any cost. So how to get BC? First write the equation in X direction, you get FBC. Then go and sit here and write the moment equation. No need to write in Y direction. Now please see. In X direction, is it in static or dynamic equilibrium? It's a truss. So it is a truss, static equilibrium, it's a structure, right? In X direction, what are the forces I have? See, in X direction as it is in static equilibrium, net sum of all the forces is equal to 0. FBC cos theta in this direction. So minus FBC cos theta. Next, 800 cos 60 minus 800 cos 60 is equal to 0. So what will be FBC? See, you send it that side. So plus 800 cos 60, even one minus is there. So minus 800 cos 60 by cos theta. Okay, keep it. We'll solve it, sir. Keep it. Okay, I got FBC. Next, go for the moment. So as it is in static equilibrium, sigma m is equal to 0. So where you have to sit? See, if I sit here, AB will go. So I will go and sit here because I want to find AB. Are you getting? FCD, moment due to FCD, 0. 800 cos 60, 0. 800 sin 60, 0. All the three are here. Even FBC cos theta is 0. Right? So I have only three forces. BC sin theta, AB 600. So what I can write? So moment with respect to which point I'm taking? D. Now please all of you see here. First, let us start with 600. Clockwise or anti-clockwise? Anti-clockwise according to us is positive. And what is this length? 3 meters. This is 3 meters. Okay. So 600 positive 3 into 600 anti-clockwise positive. Next, FAB clockwise. So minus 3 into FAB. Even FBC sin theta clockwise. So minus 3 into FBC sin theta. So what is common in all the three? See, everything is at the same distance. So 3 is common. So 3 common. I want FAB. So FAB is equal to, see, minus FAB. Send it this side. What I'm left with? 600 minus FBC sin theta. What is FBC, sir? Already I have. Minus of minus plus. So 600 plus 800 cos 60. Sir, what is cos 60? Already I know cos 60 is how much? 1 by 2 into sin theta is there on the top by cos theta. So what I can write? 600 plus 400 into sin theta by cos theta is tan theta. Okay. Now from this equation, what is tan theta? Sorry, from the triangle, what is tan theta? Very good, I'm getting this. What is tan theta? Opposite side is how much? 4. Adjacent side 3. 4 by 3. So it is how much? 4 by 3. So 600 plus 400 into 4 by 3. So how much is FAB coming? By 33 plus 600. So the total FAB is coming. I'm writing on the top. How much is that? 1133.33 kilonewtons. It's coming positive. What's the meaning of that? My member is under, it's positive. My member is under compression. All of you are okay? So this is how we'll solve in method of sections. Okay? So what's the answer? 1133 kilonewtons compression. See, after getting, no need to go back, check again, nothing, right? See, directly we have, what is this? 1133 kilonewtons compression. Are you okay? Go for the next one. Force in a member CD. Please, all of you. He's asking to find the force in the member. He's asking to find the force in the member CD. This is my CD. Yes. This is my force CD. How to find the force in the member CD? Method of joints 1, 2, 3, 4. 1, 2, 3, 4. No way. So only option is method of sections. So what are the rules? Section or cut the truss into 2 parts such that my member of interest CD need to be sectioned. None of the joints should be isolated. Yes, I have more than 4, so I can do it. Next, not more than 3 unknowns are created. 4th one, if possible, try to keep both the supports on the same side. How to do that? Tell me. If I want to keep both the supports on the same side, I have to draw like this, but they are creating more than 3. 1, 2, 3, 4, 5. Any other way? So there's no chance that I can keep both the supports on the same side. So I don't have that option. So only option is. Are you okay? Now see, my member of interest is section. First condition. Second condition is what? None of the joint is isolated. On this side 3 are there. On this side C. On this side ABC. On this side DEF. 3. So none of the joint is isolated. Not more than 3 unknowns. See, 1, 2, 3. It is cutting 3 members. So 3 unknowns are only created. Are you okay? Not more than 3 unknowns are created, but I am not able to keep both of them on the same side. So you have to find support reaction. At which point you will find A, R, F. Here both are easy only, but I will say here there are 2 support reactions. Here only 1 support reaction. So I will go and sit here and take the moment. So I will get at F. But even you can find at A also, because this is only A. RAX, that is the only force in the horizontal direction, so directly it is 0, so you can go and sit here. Even if that is not 0 also, that force is passing through F, so that is eliminated. You can get RAX also directly. But anyhow, I'll find the support reaction at F. So what's the first case? I'm doing it, but directly here you can sit, just simply write L into 1, 2L into 2 is equal to 3L into RF. But I'm not going to do that now, okay? I will do with the method. So please, all of you, see here. What's that? First step. As I want the support reactions, first I'll find support reactions. So what's that? Consider the entire truss to be a single body. And find the support reactions. Consider the entire truss to be a single body and find the support reactions. Okay. It's more lengthy. Yeah, fine. We have to adjust. Consider the entire truss to be a. They are not coming with the equal dimensions, but anyhow, I adjust it. This is the direction, right? Okay, just Consider the entire truss to be a single body and draw the sketch. Done. Next, actions. There's a 1 kilonewton load at C and 2 kilonewtons load acting down at E. So two loads. 1 kilonewton here, 2 kilonewtons here. Fill the body from everything and draw the sketch. Done. Next, actions. Two forces are there. How many forces are there? Two forces. 1 kilonewton down and 2 kilonewton down. Done. Next, reactions. At A, I have a hinge support, and at F, I have a roller support. As there is a hinge support, maximum how many I will have? Two support reactions. RAX, RAY. And at F, it's a roller support. As it is a roller support, I will have only one support reaction, right? So RAX, RAY, and here only RFY. Okay. Now please, I want RFY. Even this is easy because RAX is 0. Go and sit there. But anyhow, I will sit here. Okay. Moment due to RAX 0. Moment due to RAY 0. Now, please, all of you see here. No hurry, sir. No hurry. Moment. It is in static equilibrium. So sigma m with respect to A is equal to 0. Moment due to RAX 0, RAY 0. Now 1 kilonewton. See, what are the lengths? See, L. Assume for the timing, okay? As the software didn't cooperate, I was not able to get it, okay? L, okay? Now, from here, clockwise or anti-clockwise? Clockwise. So, minus 1 into 1. Sorry, L into 1. Next. How much distance? 2L. How is it? Clockwise. So, minus 2L into 2. Next. RFY. 3L into anti-clockwise. So, plus 3L into RFY is equal to 0. So, how much I will get? L minus 2 2s are 4L. So, minus 5L. I'll do one thing. You send these to that side. So 3L into RFY is equal to 2 2s are 4L plus L. So it is 5L. So both negatives will become positive. So L gone. RFY is equal to 5 by 3. That means it is 1.66 kilonewtons. So now I know the value of the support reaction here. How much is this? Now I know this. RFY is equal to 1.66 kilonewtons. I got positive, so my assumed direction is correct, upwards. Okay. Now, as I know the support reaction there, I will see any side you can draw, sir. Any side you can draw. But if you want to draw this side, find out the support reaction side A. If I want to draw this side, I have found out the support reaction side F. Okay. Now what to do? Now draw the free body diagram of either side. Now I'll draw for this DEF. Okay. So it's a right angle triangle, right? We have a right angle triangle. Yes. Both are L and L. Okay, almost fine. Good. Now, next, DEF done. Now, fill the body from everything and draw the sketch. Done. DEF done. Next, actions. What are the actions? At E, I have a 2 kilonewton load. And this is a known reaction. How much is that? 1.66 kilonewton. So what I will do? At this point. Okay. I have how much? I have 2 kilonewton, and here I have a known reaction acting upwards. How much is that? 1.66. So this is 2 kilonewton vertically down, and here I have 1.66 kilonewtons acting upwards. Next. Fill the body from everything and draw the sketch. Done. Actions and known reactions. This is also done. Next, reactions. See, it's cutting at 3 points. It's cutting at 3 points. What are the 3 points? BD, CD, C, BD, CD, C. Okay, BD is horizontal, CD is inclined. See, this is L, this is L, this is L, this is L. How much is the angle, sir? 45 degrees. Okay, okay. So FBD, FBD. And here I have one more. Here I have one more. What is that? One more. FCE. And here I have. What's that? What's that? Sorry, that is C. FBD, CD, CE. C is in the bottom. C is in the bottom. This is C. This is C. Okay. Fine. This is FBD, right? Yes, FBD. FBD. FCD, making an angle 45 degrees, either with horizontal or vertical. I don't have any objection, okay, because both are same angles. 45, 45, because that's why you can take anything. FC, okay, okay. So BD, CD, CE. He is asking CD. He is asking CD. I want to get this CD. I want to get this CD. So the only force which is inclined is also CD. The only force which is inclined is also CD. First resolve this. First resolve this. So this is FCD. 45 is this, so this is opposite, so sine 45. When it is 45, anything you take, you will get the same one, but follow, sir, follow. And this is cos 45. Now FCD, how to get FCD? In horizontal direction I have more unknowns, but in vertical direction I know these two. The only unknown is CD. So just write down the equation. Just write down the equation in y direction. Static or dynamic? As it is in static equilibrium, sigma Fy is equal to 0. Tell me what are the forces? 2 kilonewton is acting down, so minus 2. FCD cos 45 is acting up, so plus FCD cos 45. 1.6 is also acting up, so plus 1.66 is equal to 0. So FCD is equal to C, minus 2. If you send it that side, plus 2, plus 1.66, minus 1.66 by cos 45. So 0.48 kilonewtons. What is it coming, sir? What is it coming? Positive or negative? Positive. What's the meaning of this positive? Again, it is under compression. Compression. So what's the answer? 0.471 kilonewtons compression. Am I right? Yes. Okay. So next question. Yes, this is the next question. This is the gate question given for me in 2014. At that time, I don't know how to solve trusses and frames, so I didn't get those 2 marks. So please, all of you, see here. Just start your stopwatch. 2 minutes, I'll solve the problem. For the truss shown in figure, F1 is 9 kilonewtons and F2 is 3 kilonewtons. I will solve it here. I will solve it here. I won't. Okay, fine, because yeah, you are in the initial stage. I am in the stage. So let us. F1 is how much? 9 kilonewton. F2 is 3 kilonewtons. Force in member QS. Force in member QS. This is the member QS. This is the member QS. So he's asking what's the force in the member QS. Okay. Okay. Now tell me what to do. What to do? Check for method of joints. 1, 2, 3, 4. No way. 1, 2, 3. Only 2 unknowns can be found. So no way. Go with method of sections. Section, cut the truss into 2 parts such that my member of interest is section. Okay, I want to cut this. Next. None of the joint is isolated. There are 1, 2, 3, 4, 5. Anyhow, I can go. Next. Not more than 3 unknowns are created. If possible, keep both the supports on the same side. How can I do that? How can I do that? Listen. See. This is the member to be cut. Keep these 2 on the side and draw like this. Now, PQ, QS, my member of interest is section, and ST. See, my member of interest is section. On this side 2 are there, on this side 3 are there. None of the joint is isolated. Not more than 3. 1, 2, 3. Only 3 are created. Can I solve or not? And I have got luckily 2 on the same side. So draw the free body diagram on the other side. What's the other side? PS. What's the other side? PS. Okay. Okay. You can solve it there itself. But as everyone has not become an expert, I'll go a bit slow. So QS. Any specific angle? 1.5, 3. Okay, fine. This is my PS. Okay, this is my PS. So free the body from everything and draw the sketch. PS I have drawn. Next, actions. On PS, what are the actions? Only at P I have a load 9 kilonewton acting vertically down. Only at P I have a load 9 kilonewton acting vertically down. Vertically down. F1 9 kilonewtons vertically down. Any other actions? That's it now. Only F1. Next, reactions. Tell me. FPQ, FSQ, sorry, QS and FST, right? So 3 are there. One is FPQ. One here, FPQ. At this angle, FQS. And this is FST, right? This is FPQ, and I have to find this, that is FQS, and this is FST. Free the body from everything and draw the sketch. Done. Action done. Reactions also done. Right? See, 1, 2, 3, done. Okay? Now, how to get this QS? Sir, except this QS, everything is in either. What's that? Except this QS, everything is in either horizontal or vertical direction. So first what to do? Resolve this. If I want to resolve, first let me find out the angle. Let me get the angle. Let us say. I'm drawing it here. Let us say I want this QS, right? With the vertical. It's making an angle theta. Okay. Yes. Now with the vertical, it's making an angle theta. So I have two components. What are the two components? One in this direction, that is FQS cos theta, and one along this direction, that is FQS sin theta. What is it I want to find? QS. See, if I take in horizontal direction, 1, 2, 3 unknowns are there. If I take in vertical direction, only QS cos theta, 9 kilonewtons. No need of even moment. See, what y direction, only these two are there, right? So that's how in GATE they will give you the simple way to solve it. You can solve in no time, but the only thing they test is whether you know that concepts or not. In y direction, sigma Fy equal to 0. Next, 9 kilonewton is acting down, so minus 9. QS cos theta is also acting down, so minus QS cos theta is equal to 0. So FQS is equal to, see, I'll send this that side. So FQS cos theta, minus 9 is left out. By cos theta. How much will be this? This length. So 1.5. Because already 1.5 gone here. 3 out of that 1.5 meters. Next, what I know? This is 2 meters. How much will be this? Listen, if you don't want to take under root of 2 square plus 1.5 square, see, 3, 4, this will be 5. 3, 4, this will be 5. Now it is half, 1.5, 2. So this will be 2.5. So how much is this going to be? Cos theta. Adjacent side, 2 by hypotenuse, 2.5. 2 by 2.5. 2 by 2.5, right? So FQS is equal to minus 9 by 2 by 2.5. It will become 2 by 2.5. 2.5 will come onto the top. 2.5 by 2. So how much is this coming? Pakka 11.25 kilonewton. Minus indicates, yes, Bharat, you are correct. Minus indicates it is under tension. No need to check again and all whether I have taken like this, like that and all. Positive compression, negative tension. Always along the line towards the joint. Take towards the joint. So don't take away from the joint and say, sir, minus came and all. Don't change the signs. Always towards the joint. Positive compression, negative tension. That's it. So what's the answer? 11.25 tension. 11.25 kilonewtons tension. All of you are okay? Following me? This is also a very good problem. Please, all of you see here. For the truss, loaded, supported as shown in figure, determine the force in the member CD, PG and GH. Very good. Now, what's that? So here 3 are there, okay? So all the 3 need to be cut. Not more than 3 unknowns are created. None of the joint is isolated. How can you do that? How can you do that? See, here we can do that. Here you have the option. What is that option is? Cut like this. CD, DG, GH. So all my requirements 3 are sectioned, only 3 unknowns are created, none of the joint is isolated. On this side there are 3, on this side there are more than 3, right? But the only thing is I am not able to do what? Keep both the supports on the same side. Okay, fine, we have to adjust because it's very complicated, right? Now what to do? Free the body from everything and draw the sketch. Or maybe step 1, consider the entire truss to be a single body and find out the support reactions. So A and B, which one is easy to find? Both are easy, sir. Why? Because see, at B I have 1 support reaction, here I have 2 support reactions, hinge support, but still RAX is 0 because there is no load in the X direction, there is no load in the X direction at all. Okay, so if you find at B, you have to draw the free body diagram for this. If you find at this, you can only draw for this. So it's looking simpler. ACG is looking simpler. So I'll find the support reaction at A. Whichever is simple, we'll do that. Why to take the trouble? Now, first find the support reaction at A. You can, here itself you can find directly, but I'll take one extra step, sir. I'll take one extra step, okay? Just a minute job. 1, 2, 3, right? 3. Fine. So what's the first step? Free the body from everything and draw the sketch. Free the body from everything and draw the sketch. Yes, free the body from everything and draw the sketch. It's done. Next, actions. What are the actions? At G I have a 10 kN load acting down. At H I have a 20 kN load acting down. Okay. So 2 actions. What are the 2 actions? At G I have a 10 kN load down. And here I have a 20 kN load down. 10 and 20 down. Okay. See here 10 kilonewton, here 20 kilonewton. This is 10 kilonewtons. This is 20 kilonewtons. Okay. Next, free the body from everything and draw the sketch. Next, actions done. Go for the reactions. At support A, I have hinge support, so 2 support reactions. At B, roller support, so I have only 1 support reaction. Okay. So this is and this is okay. So free the body from everything and draw the sketch. Done. Actions are, I have taken 10 and 20. Reactions at A, hinge support, 2 support reactions. At B, roller support, so 1 support reaction. Done. I want RAY. What about RAX? Because that's already 0, we can directly get it. Why? In X direction it is in static equilibrium, so net forces in X direction sigma Fx equal to 0, and the only force I have is RAX, so that is 0, no problem. What about RAY? How to get it? Go and sit at B. Sir, even if you don't find RAX also, RBY is 0, RAX is passing through this point, so this is also 0. Are you getting me, all of you? So this is my point B, right? Yes. Moment, static equilibrium. As it is in static equilibrium, what can I write? Sigma m with respect to B is equal to 0. Now sit at B. RAY. Clockwise or anti-clockwise? Clockwise. How much length? All are 3 meters, right? 3 meters. So in total 9. So clockwise minus 9 into RPY. Next, 10 kilonewtons. Anti-clockwise. So as it is an anti-clockwise, plus 6 into 10. Next, 20. Anti-clockwise. So plus 3 into 20 is equal to 0. So how much is that going to be? Send it that side. So 6 tens are 60, 2 20s are 60. That is 120 is equal to 9 RBY. So it's coming positive, so my assumed direction is cut. 120 by 9. What is 120 by 9? 13.33. So 13.33 kilonewtons. I'm taking with B na RAY into 9. I'm sorry. This is A sir. Just you are habituated for this. RAY equal to 13.33 kilonewtons. Okay, I got this. So it's coming positive. My assumed direction is correct. Okay. Now go back. And now what to do? So I know this support reaction. So draw the free body diagram of this side. What is this side? AGCR, ACG. Okay. Now please all of you, free the body from everything and draw the sketch. Okay. Free the body from everything and draw the sketch. Both are 3 and 3. Yes, 3 and 3. Very good. 45 degrees angle. So 3 and 3. 45 degrees is the angle. Okay. 45 degrees. 3 meters. Free the body from everything and draw the sketch. Done. Next, actions. What are the actions? On this ACG, only one load at G, that is 10 kilonewton vertically down. 10 kilonewton vertically down. Okay. Here. It is 10 kilonewton vertically down. Okay. Yes. Next, free the body from everything and draw the sketch. ACG done. 10 kilonewton is the only action done. Next, reactions. Tell me the reactions. CD, DG, GH. Okay, 3 I'll take. 3 are there. Okay. So here what is that? CD, DG, and then GH. Okay. DG, GH, right? Yes. CD. Yeah. So FCD, DG, GH. Now see. We forgot one more. What is that one more? I'm sorry. See, what's that? We have taken 10 kilonewton. At the time, I have one more. That is at the support A. I have a known support reaction. What is that known support reaction? How is it acting? What's a known support reaction? RAY acting upwards. 13.33 kilonewtons. Right? Here I have a known support reaction. I have a known support reaction at A. That is RAY. That is equal to how much? 13.33 kilonewtons. Yeah, please all of you see here. That's it. Fill the body from everything and draw the sketch. One action. Here known support reaction. RAX is 0. RAY is there. 1, 2, 3. Yes, done. Okay. Now. So anyhow, I want all the 3. Now, known thing, this, that, and all. Write the 3 equations and solve it quickly. Okay. First. X direction, static equilibrium. So sigma Fx equal to 0. What are the forces in X direction? FCD. In this direction, negative X direction. So minus FCD. Then GH, that is also in the negative direction. Minus FGH equal to 0. So let us say 1. That's it. Y direction. Static equilibrium. Sigma Fy is equal to 0. What are the forces in Y direction? RAY is acting up. So that is plus 13.33. Next, anything else? Minus FDG. Next, minus 10 is equal to 0. See, 13.33 minus 10 plus 3.33 minus FDG. Send it that side. So, FDG is equal to 13.3 minus 10. That is 3.33 kilonewtons. It's coming positive. What's the meaning of positive? It is under compression. I got this DG. So I have to get CD and GH. So what's the best point to sit and get it? What's the best point to get and sit it? So wherever there are more unknowns or wherever there are more forces. See, if I sit here, there are many forces. If I sit here also, there are many forces. The best point is sit here at G. Okay. Force due to 10 kilonewtons, moment due to 10 kilonewtons, 0, GH 0, DZ 0, right? So because from Varadkar theorem, moment with respect to any point you can take, that should be equal to 0 for the body to be in static equilibrium. So what I can write? Moment, it is in static equilibrium. So sigma m with respect to G will be equal to 0. Now tell me, RAY 3, this is the position vector. What is this? Clockwise. So minus 3 into 13.33. FCD. How is it? FCD. How is it? See, from here, anti-clockwise. As it is anti-clockwise, plus, sir, this is the line of action. This is the line of action. This distance. What is that? Again, the same 3 into FCD is equal to 0. So send it this side. 3 gone. FCD is equal to 13.33 kilonewtons. Again, I got positive. As it is positive, again, this is also under compression. I know FCD. Send it this side. See, I'll send it this side. Send FGH this side. So FGH is equal to how much? Minus FCD. What are you getting? Minus FGH, you send it this side. What is left out? Minus FCD, right? So that is minus 13.33 kilonewtons. That means it is in tension. It is in tension. Have I got all the three? Yes. Okay. So with this, we are done with the 15th problem. Okay. Now we have one more. Okay. Force in member BC of steel truss structure shown in figure is dash. He's asking the force in a member BC. Yes. BC, right? BC. Yes. How to get the force in a member BC? See here, listen. Force in member BC of steel structure shown in figure is C. I want to find load in this member. Anyhow, see, at B 1, 2, 3, 4. I cannot go with method of joints, pakka, method of sections. First rule, what is that? Section kar the entire truss, so that member of interest BC need to be sectioned. None of the joint is isolated. There are many, so that will not happen. Not more than 3 unknowns are created. How can I section? I can do it in 3 ways. One is like this, another is like this. Which way I have to do, sir? Both will be fine, because see, if you cut like this, 1, 2, 3, all the 3 are perpendicular. So that's why it will become easy to solve that and get this BC. Okay. So even if you do like this also, I don't have any objection. Anything is fine. You go in any manner, it will give me the same result. Okay. So which one shall we go? Yeah, fine. Yes, let me try this. Okay, so 1 BC CG GH. Here we have one more, that is cut like this. Both will work out. Okay, now I have CD HI. Okay, CD HI. So free the body from everything and draw the sketch. Both are L and L, right? Okay. This is what is given for us. Okay. Now, fill the body from everything and draw the sketch. Done. Next. See, this is what is left out. Okay. CD HI. Okay. Now, actions. What are the actions? At D, I have a load 2P1. At I have a load P2. 2P1, P2. Okay. Here I have a load 2P1 vertically down, and here I have a load P2 down. Okay. 2P1, P2. Free the body from everything and draw the sketch. Done. Actions. There are 2 actions, 2P1 and P2. I have taken them. Reactions. Tell me, BC, CG, GH. BC, CG, GH. BC, CG, GH right now. Really. BC, CG, GH, right, good, done. Next. This is BC, CG, GH. He's asking in what? BC, right? Only BC. Tell me how to do it. So only force is BC and GH. Both are in which direction? X direction. So I have to get GH if I want to find BC. What about moment? Where can I sit and eliminate it? if I sit here, I can find GH. If I sit here, then there will be a CG unknown. So better, what I'll do is, see, listen. I'll go and sit here, If I sit here, what will happen? Moment due to BC 0, CG 0. I'll get GH. From X direction, I'll get it directly. Okay? So, moment. It's in which equilibrium? Static equilibrium. So, I think only taking the previous whatever I wish to go, that is good. With respect to moment, with respect to what? C. I'm taking with C. That is equal to 0. Moment with respect to BC, gone. CG, gone. See, every distance is what? L. So this is L, this is L, this is L. Okay? Now go sit here. Start with the first one, 2p1. Clockwise or anti-clockwise? Clockwise. According to us, clockwise is minus L into 2p1. Next, GH, how is it? See from here like this. Right hand. How is it? Anti-clockwise. So, plus, what's the distance? See, this is the line of action. So it is L plus L into FGH. Next, P2. How is P2? I'm here. See, P2. Like this. So, clockwise minus, L plus L is 2L into P2. That is equal to 0. So, only, L, gone. So, FGH. I'm keeping there only. Minus 2P1, minus 2P2. So, plus 2 into P1 plus P2. Okay, I got FGH. Next, what I want? FBC. So, in X direction. Both are in X direction. So, static equilibrium. So, sigma Fx equal to 0. Tell me what are the forces? BC, positive direction. FBC. GH, that is also in the positive direction. Plus FGH is equal to 0. So, what is that BC going to be? Minus FGH. So, it is minus 2 into P1 plus P2. Okay, so what's the answer? 2 into P1 plus P2. He is asking only magnitude. So I have that option. Okay, so with this, we are done with the complete trusses. Okay, hope you have gained some knowledge from my lecture. If you feel so, please subscribe to the channel. Please leave your valuable feedback and doubts in the comment section. For my complete video lecture series, enroll in OCTEMY. Thank you. Let's catch you soon in OCTEMY. Have a good day.